The other way to solve inequalities using test intervals starts out kind of like the way you graph inequalities, where you pretend your expression contains an equals instead of whatever inequality it was. So if you had to solve this, what would you do? You might first take everything over to the other side because the negative is annoying, and you would get x squared minus 8x equals 0. Then there's a common factor of x in here. Take that out and you get x minus 8. So this has two solutions. Either x is 0 or x is 8. So the idea is that this thing, which is a parabola, and you can see that it opens down because it's got the minus x squared in it, has an x-intercept at 0, 5, 6, 7, 8, and another one at positive 8. Those are the two places where it crosses the x-axis. What we want is for 8x minus x squared to be lower than 0. So how do we know when that happens? It should be, I'm just going to get rid of the y-axis, we'll do this a different way. The only places where anything interesting could have happened in this equation are at 0 and 8. So what we want to do is check between those two values. We have to check out here, lower than 0. That's our first region to check. Between 0 and 8, zone number 2, and above 8, zone number 3. We're going to pick any number that we want in that region and see if it satisfies the inequality. So for instance, out here, I'll use, totally making this up, x equals negative 2. We're just taking any number that's lower than 0. So our inequality says 8 times x minus x squared has to be less than or equal to 0. That gives us minus 16 minus 4 is less than or equal to 0. Negative 20 is less than or equal to 0, so that's a yes. Meaning region number 1 is part of our solution. Does 0 work? If you try that, you get 8 times 0 minus 0 squared is less than or equal to 0. That becomes 0 is less than or equal to 0, and yep, that's part of our solution as well. 0 is equal to 0. How about in the middle, between 0 and 8? Oh, I'll take 1. 1's a nice number. 8 times 1 minus 1 squared, less than or equal to 0. I'm taking 1 because it has to be any number between 0 and 8, so plug that number in and then you just see if it works. We get 8 minus 1 is less than or equal to 0. 7 is less than or equal to 0. No! That is false. Meaning 1 did not work, meaning nothing in this region is going to work. We picked number 1 that was in this region and it failed. Any other number that you picked in here will fail the same way. So next thing we have to do is try 8. Does 8 work in this expression? 8x minus x squared is less than or equal to 0. 64 minus 64 is less than or equal to 0. 0 is less than or equal to 0. That is true. So the point 8 is part of our solution. And last one, we need a number higher than 8. 10 is nice. It's easy to do math with 10. 8 times x minus x squared less than or equal to 0. 80 minus 100 less than or equal to 0. Negative 20 is less than or equal to 0. That's a yes. So now we have another piece of solution. Make sense? You find the edges, the equal points, and then you check all around them. Check to the left of them, check to the in between them, check to the right of them, and that's how you build up your solution. In this case, the solution is x can be less than or equal to 0. That's this left-hand piece. Or x can be greater than or equal to 8. And you can throw in the XER if your teacher likes to see that. They don't always show you to check right on the boundaries here, to plug in 0 and to plug in 8 and see if they work. I think it's a good idea. You'll never regret doing that. It does allow you to confirm whether this should be equal to or whether there should be an open circle here for not equal to. So it may not be part of the official steps, but I encourage you to do that too. It's just a little bit more work, which is too bad. But so you check. These are the 3 checks for when you're between 0 and 8, and then we also checked right on 0 and we checked right on 8 to see if those satisfy the expression or not.